Hi friends, welcome back on our YouTube channel. In today's lecture of classical mechanics, we are going to discuss about canonical transformation. So, here we will discuss about canonical transformation for a holonomic bilateral dynamical system with n degrees of freedom. The choice of n generalized coordinate is arbitrary. Thus, it is required to transform from one set of generalized coordinate to another set of generalized coordinate. One set of generalized coordinate are small q1, q2, qn, and the next set of generalized coordinate are the set of capital Q1, capital Q2, capital Qn. So, we are required to transform from one set of generalized coordinate to another set of generalized coordinate, and this transformation is known as point transformation. So point transformation is a transformation in which we transform old coordinate to new coordinate. It means small q1, q2, qn to capital Q1, q2, qn. Transformation is our point transformation. By point transformation, the transformation in Lagrangian is L to L dash, and this Lagrangian, that is old Lagrangian, is a function of old coordinate, old velocity and time, that is small qi dot and t, and this new Lagrangian, which is L dash, is a function of new coordinate, new velocity and time, that is, it is the function of capital Qi dot and t. Due to this transformation, the new momenta is capital Pi is equal to del L dash upon del capital Qi dot. So this is our new Lagrangian, this is our new velocity. It means this will be our new momenta. And this Pi is a function of old coordinate, old momenta and time. It means capital Pi is a function of small pi and t. Thus, the new momenta are defined in terms of old coordinate, old momenta and time. Thus, the general form of the point transformation is capital Qi, and capital Qi is a function of small qi and t. Means the general form of point transformation is Qi is a function of small q1, small q2, small qn and t. So this is the function of old coordinate and time. And the new momenta is a function of old coordinate, old momenta and time. The corresponding inverse transformation is a small qi, and small qi is a function of capital Qi and t, and a small pi, that is old momenta, is a function of new coordinate, new momenta and t. So this is our point transformation from old coordinate to new coordinate, and this is our inverse point transformation from new coordinate, new momenta and time to old coordinate and old momenta. The Lagrange's equation of motion for L and L dash is invariant under point transformation. The point transformation are always defined in configuration space, and it is found that when Hamilton's equation of motion are used to describe the dynamics of the system, then the point transformation given by capital Qi, and capital Qi is a function of old coordinate and time, and capital Pi means new momenta is a function of old coordinate, old momentum and time, and inverse transformation is small qi is a function of capital Qi and t, and old momenta, that is small pi, is a function of capital Qi, capital P and T. So new coordinate are the function of old coordinate and time. New momenta is a function of old coordinate, old momentum and time. Old coordinate is a function of new coordinate and time. Old momenta is a function of new coordinate, new momenta and time. It is replaced by a phase space transformation given by capital Qi is a function of old coordinate, old momentum and time. Capital Pi is a function of old coordinate, old momentum and time. So when Hamilton equation of motion are used to describe the dynamics of the system, then the point transformation given by this are replaced by a phase space transformation given by this one. The Hamilton principle must be invariant under this transformation. Therefore, delta integration T0 to T sigma I Pi Qi dot minus H dt is equal to delta integration T0 to T sigma I capital Pi capital Qi dot minus K dt equals to 0. So this is our old momentum, this is our old velocity, and this is our old Hamiltonian, and this will be equal to sigma I Pi Qi dot minus K. This is our new momenta, this is our new velocity, and this is our new Hamiltonian. And since this Hamiltonian is represented by K, so it is sometimes known as Kamiltonian. And H is a function of old coordinate, old momenta and time, and new Hamiltonian is a function of new coordinate, new momenta and time, and this will be equal to 0. Here K, which is the function of capital Q, capital P and T, is the transformation in Hamiltonian. Above equation requires that Pi dot is equal to minus del K upon del capital Qi, and Qi dot equal to del K upon del Pi. And this equation must be satisfied by the new coordinates and new momenta, that is capital Qi and capital Pi. The phase space transformation that preserves the canonical equation of motion are called canonical transformation. So this is our canonical transformation. Here we are ending our this lecture. Soon we will be available with another lecture of classical mechanics. Till then, goodbye.